Here we have a geometry problem. There is a figure given over here. In the figure above, AE equals to DE, CD equals to DB, measure of angle EDC equals to 80 degree, measure of angle ACD equals to 20 degree, and measure of angle DCB equals to x degree. Find the value of x. Okay, in the given figure, we have to find the value of x over here. Okay, first let me consider the triangle CED. In this triangle, two interior angle measures are given, 20 degree, 80 degree. And what is the measure of the third interior angle? Already we know that in any triangle, three interior angle measures will add up to 180 degree. So we know that this is 20 and this is 80. To know the measure of the third interior angle, we have to add the given two interior angles 20 and 80 and subtract it from 180. So when I add 20 and 80, I'm getting 100. When I subtract 100 from 180, I'm getting 80 degree. So the third interior angle measure over here is 80 degree. So now we can verify by adding the three angle measures. When I add 80 and 80, I'm getting 160, 160 positive 20, 180. So this three interior angle measures over here add up to 180. So the answer I got for the interior angle measure at vertex C is correct. Okay, already we know that this is a straight angle over here because we have this angle measured on the straight line AC, and always the straight angle measures 180 degree. If this part is 80 degree, then what is the measure of this part? So for that, we have to subtract this 80 degree from the straight angle 180. If I subtract 80 from 180, I'm getting 100. So the measure of the angle measure over here is 100 degree. So even if I add 180, I'm getting 180 degree. That's the angle on the straight line. Okay, so there is an information in the question, that is the line segments AE and DE are equal. That is, this line segment AE and DE are equal. In a triangle, if two sides are equal in length, the interior angles which are opposite to the sides of equal length must be equal in measure. So here the interior angle at vertex A is opposite to the side DE, and the interior angle at vertex G is opposite to the side AE. Since these two interior angles the interior angle at the vertex A and interior angle at the vertex D are opposite to the sides AE and DE, which are equal in length, so these two interior angle measures must be equal. Okay, I assume the interior angle measure over here is y degree. Then what must be the interior angle at the vertex D? So this one also must be y, because these two interior angles are opposite to the sides of equal length AE and DE. So they must be same, y and y. And now this y degree, this y degree, this 100 degree. So these three angle measures are interior angles of the triangle AED. So these interior angle measures must add up to 180 degree. That is y degree, positive y degree, positive 100 degree equals to 180 degree. Okay, now let's solve for y in this equation. When I combine these, the first two terms, I'm getting 2 times y degree, positive 100 degree equals to 180 degree. Okay, now let's subtract 100 degree from both sides. When I do so, I'm getting 2y degree is equal to 80 degree. So when I divide both sides by 2, so this 2 will cancel out. I'm getting y degree equals to, when I divide 80 degree by 2, I'm getting 40 degree. I got the angle measure y degree, that is 40 degree. So we can replace this y degree by 40 degree. So here we have 40 degree, here we have 40 degree. Okay, we know that this is the angle on the straight line AB and it measures 180 degree. In this straight angle 180 degree, this part is 40 and this part is 80. So what is the measure of this part? So for that, I have to add these two angle measures and subtract from the straight angle 180 degree. When I add 40 and 80, I'm getting 120. When I subtract 120 from 180, I'm getting 60 degree. So here the angle measure has to be 60 degree. So now we can verify by adding this one, and this one. So when I add 40 plus, when I add 40 and 80, I'm getting 120. 120 plus 60 will be 180. Okay, now I got the angle measure 60 degree over here. Okay, and also there is an information in the question, that is CD and DB are equal. That is, in the triangle BCD, the line segment CD and the line segment BD are equal. Okay, in a triangle, if two sides are equal in length, the interior angles which are opposite to the sides of equal length must be equal in measure. So this angle measure is opposite to the side BD and this interior angle measure opposite to the side CD. So these two interior angles, I mean the angle measure over here, the angle measure at the vertex B are opposite to the sides of equal length CD and DB. So these two angle measures must be equal. So already we know that the angle measure over here, there is x degree. Then the interior angle at vertex B also must be x degree, because these two interior angles are opposite to the sides of equal length CD and DB. Okay, now we know the three interior angles of the triangle BCD, and these interior angles x degree, 60 degree must add up to 180 degree, because they are the three interior angles of a triangle. So now I can add x degree, positive 60 degree equals to 180 degree. Okay, when I combine this x and x, I'm getting 2x positive 60 equals to 180. And when I subtract 60 from both sides, I'm getting 2x equals to, when I subtract 60 from 180, I'm getting 120. So let's divide both sides by 2. So this 2 will cancel out. X equals to, when I divide 120 by 2, I'm getting 60. I got the value of x in the given figure. So the value of x is 60.